today's class we're going to have an introduction to C#, very similar to other programming languages you've used, but just go through the basics of it, and then we'll do a little test in Unity. Other things we're going to do in Unity today, we're going to import a character controller, a third-person character controller, and we're going to start importing our Blender level assets and setting them up so we can use them. As well as introducing ourselves to a little bit of coding. So coding, character controller, and Blender level assets, that's what's happening today. Variables, functions, classes, and how to use them. So, scripting is what makes everything happen in Unity. It tells our game objects how to behave. It's the scripts and components attached to the game objects and how they interact with each other that creates your gameplay. If you think of the old Jewish folklore legend of the golem, do you know the legend of the golem? No? You don't know Jewish folklore? Crazy. I thought this was a college, man. Yeah. Basically, the golem is a man made of clay. A giant hulking man. And inside his head, they write script, Jewish script and prayer, and give it commands. The golem performs the commands, and then once it's finished, it crumbles to dust. That is the legend of the golem. Our game object is our golem. Game objects will not move or do anything we tell them without scripts, our magic words that we put inside its head. Nice metaphor? Cool. Our golem object. The scripting in Unity is different from pure programming, as in it's easier. So if you've done some pure programming, you create a running app, you should realize in Unity you don't need to create the code that runs the application, because Unity does that for you. So the whole engine, the physics world, all the 3D rendering stuff is handled for you. Instead, you focus on the gameplay in your scripts. So Unity runs in a big loop. It reads all of the data in the scene. For example, it reads through the lights, the meshes, what behaviors are, and it processes all this information for you. And when does it run all this information? When we're in Unity? When you start the game? Yes, correct. When you start the simulation, you press play, it starts the loop, it initializes all of this stuff. If you think about television, where you have 30 frames per second as a default, Unity needs to do the same thing. So it's running single discrete frames, one after another. And you direct Unity with the instructions that you write in your scripts. And Unity executes them frame after frame as fast as it can. So the goal in gaming is usually you want to maintain 60 FPS, pure smooth running speed, but things can't deviate and slow down. Human vision can actually only just about process 24 frames per second, which is the standard for television. It was the standard for decades, almost a century. It's only with the advent of digital media that we start being able to produce higher frame rates, 30 FPS, 60 FPS, frames per second. So this is all 1 second of time. Achieving a high frame rate means not only will your game look more fluid, but your scripts will also be executed more often, making controls more responsive. So it's not just about lag with the graphics, the game itself is slowing down with the frame rate. What languages can you use in Unity? What language can we use in Unity? C#. C#. Any other languages? C, C++. Anything else?
Python?
I don't think Python. I think Boo used to be accepted. Java. Oh yeah, Java. Yeah. But it's a certain kind of Java that is written through C#. So. Hey, come on in. Morning. But in, I would say, 99% of game studios that use Unity, it is C#, simply because that is what Unity is optimized for. It's also what you find almost all of the tutorials you look up will be written for C#. Very few are written for Java or written for Python or anything like that. There are a few that are written for the code block system, where you connect code blocks up. We might have a look at that at some point. For now, focus on this. Yeah, so I don't need to read this slide. You said C#. You are correct. This is C#. Here is our script. And here are a couple of functions. Function 1. Function 2. Function 3, function 4. We'll take a look at what they do later. So yes, C#. So all the languages that Unity operates in are object-oriented scripting languages. So like any language, scripting languages have syntax or parts of speech called variables, functions, and classes. Variables hold values for us and references to objects. You can see objects as bigger variables. They're like a box that holds something for us to use. Variables start with a lowercase letter. Functions are collections of code that manipulate those variables. They start with an uppercase letter. These are just rules that we follow. We organize code in functions so they can be easily reused multiple times in any project. Here is a function called myMethod. What is it? What is it telling us is going to happen?
If 1 is greater than 2, then it'll give you an output of change places.
Yep. And if it's not,
then it's in a single.
you know your if-else statements already.
Yeah.
Fantastic. It's like Twine 2. We're back. You need a gold key to open a gold door. Oh, we're back to if statements. Variables, as I said, they hold values. The scripts start by laying out the tools you need at the top, and this is usually by declaring variables. So you declare your variables at the top of the script outside of your functions. And what I mean is, if this is an entire function here, with its opening and closing curly brackets, again, just like CSS, we have opening and closing tags, then we would write our variables up here. Let's say I needed a float for speed. Float speed equals 10f. It's declared still inside the curly brackets of the class, but outside the curly brackets of the method. And here are two variables holding types light. So these are game object lights that are in our scene. We're holding them as variables so we can modify them.
So why are they capitalized?
Pardon?
I thought you said the variable is the first letter is lower, but here we're
That's the name of the variable. That is the variable type. So capital letter for the variable type. If we're referring to a game object in our scene, capital game object, and then the name we give it lowercase. You can also see the declare variables with the visibility public or private, followed by a type and a name. If we create this script in Unity, you'll see we can access the light variable declared as public in the inspector, so we can see it in Unity because it is public. We can't see the private one, as the private variable can only be accessed within this script. The public variable means we can access it in the Unity inspector, and also other scripts can access it. Why use private? Cleaner code as values are only changed in this class, so you only need to worry about one script changing that class, and you know it's this one. It's easier to debug and maintain. Why use public? Again, it can make things easier for you in other ways. Objects can communicate between themselves, and if you experience an issue, you need to look through all codes to have access to this variable, whereas if it's public, you can see just by clicking in the inspector, oh, there's that variable there, and see what it's doing. type. So light is the type declared for this one. Defines what kind of value that the variable is holding. It can be a number, text, or more complex types like the ones in the image below. Transform, light, and demo script in the image are in fact references to components. Our transform, our light, and our demo script components. So Unity needs to know what type of object it is so it knows how to handle it.
Can we select the subcategory as well, such as color, range?
Yes, yes. So any of the components will have subcategories within them. So yeah, we can access the range, we can access the color, we can access its on or off state,
Intensity.
turn on or off. Any one of these properties can be accessed within the script to refer to it by the light component. So we get the component of light and access it that way. Say with the transform component, we can access the position, rotation, or scale of any game object just by looking at the transform. Naming. Another important thing about variables is the name. When naming variables, it is that it can't start with a number. Hello, Tony. It cannot start with a number, and it cannot contain spaces. So underscores instead of spaces are fine. If you put a space, then it's like it's going to start a new variable. What's up?
Oh no, it's something with Rebecca Berkwick.
Oh,
Sorry to
Okay.
disturb the class.
cool. Go ahead.
Whenever you stop dating those others.
Okay. Fine. So, in C#, the naming convention is camel case. You start with a lowercase letter and then add words without spaces starting with a capital letter, e.g. my light or camel, like the humps in a camel. That is the standard camel case. There's also kebab case, words on a skewer, screaming snake case, underscores, lower snake, upper camel, but I just stick with camel case as a convention. Makes things easier. Functions. So scripts manipulate the variables by using functions. There are a number of functions that run automatically inside Unity. Awake, start, update, fixed update, and late update. So, they're written basically in the order that they run. The start runs at the very start of the game when we press play. Awake runs just before that, when the game just wakes up. So things you might want to initialize before the level starts, we put in there. Let's say you want to initialize all your camera stuff before your level starts. You want to separate them. Update and fixed update run once per frame, or as fast as they can. The difference being update runs as fast as it possibly can. Fixed update runs in time with the physics engine. So if we're manipulating rigid bodies in physics, we generally use fixed update for that. An update for anything else that we want to run every frame. Late update, again, updates every frame, but it happens after these updates. So generally used for camera controls for late update, because after we've initialized the character, the physics, and the controls, we want the camera to happen then. Awake, as I said, called once when the game object with that component is instantiated. What does instantiate mean? No. Instantiate. You've heard this word before.
Initially set
It's
to
called.
starting time.
It's called
Created.
creation. Yeah. It is. It's creating duplicates, copies, instances of the initial. So instantiating and destroying objects is considered very important during gameplay. So instantiating simply means bringing into existence. This method, defined in modern behavior, takes in a game object as a parameter, so it knows which game object to create. Duplicate. So if you've ever played a game where you're firing bullets, they are all the same bullet, be being copied again and again and again. It is one prefab being duplicated every time you press fire. Awake, as I said. If the game object is inactive, then it will not be called until it is made active. So when the object that this script is on is awake, it will initialize the variables that you need. Start, like awake, it'll be called if the game object is active, but only if the component is enabled, called at the start of the game. Update, called once per frame. This is where you put code to define the logic that runs continuously, like animations, AI, and other parts of the game that have to be constantly updated. Maybe you need to constantly update with the player position so that enemies can find it. Something like that. And then fixed update, as I said, is when you want to do physics work. It'll only update in step with the physics engine. And you can see this graphic explaining it here. Here's update, every single frame is updating. And fixed update, only in step with the physics engine. So it skips a frame. And the one thing we're going to find as we're designing our character controllers is that some things, like our character controls, work in fixed update very well, and some things don't. So controlling and moving a character with physics forces, fixed update. If we add a jump to that character, it needs to be an update, because a jump needs to be able to execute the second the player presses it. If you put it in fixed update, and we will test this, you notice sometimes you press it, it doesn't work because you're hitting the frame when it's not refreshing. So yeah.
Really sorry, I don't understand the difference between fixed update and a normal update. Like, for example, like you damage an object, so where is that going to fall? In fixed or just a normal update?
Well, what do you mean by damage?
Like, there's an object in front of me. As a user, I'm going to kick the object. The object is now deformed, basically.
Sure.
So
that would be with update then, yeah, because you want to register every single frame to make sure you don't miss the impact.
exactly, yeah, because that's what I was thinking. Like, if it's going to be in a fixed update, it's going to be coming in a gap, so the object's going to return back to normal.
Yeah.
Then deformed.
And the thing is, that wouldn't be a physics manipulation. You wouldn't be using physics forces to hit that object. If you were, if you're like, it was a push, and you're like, oh, I want to push this object like using physics forces, I use fixed update for that, because it'll execute in time with the physics engine, updating gravity and all that. Anything else that needs to be immediate, again, I use the jump example, you need that to be an update. So be as responsive as possible. So we always use fixed update for physics. Late update, as I said, camera controls. It's called at the end of the frame. So you need to look at all game objects, find all the updates, and then call the late updates. Common use is for camera. If you make your character move and turn inside update, you can perform all camera movement and rotation calculations in late update. Separate them. This will ensure that the character has moved completely before the camera tracks its position. Functions. Still on functions. So when writing a function, remember to start with the returned type of the function at the beginning, followed by the name of the function, and then the parameters in the parentheses, if any. So what do I mean? What is the returned type of this function right here? If we start with the return type.
The return type?
What is the returned type? If I say every function starts with the return type.
It's void, nothing.
Hey! Bam! 10 points. Hufflepuff. I don't know. Yes, void. So any function that starts with void means it doesn't return a value. It's not calculating to return a numerical value. It's returning a result, but it's not returning a numerical value. So this one, function, means mylight enabled equals exclamation point, mylight enabled. This means not, basically, the opposite. So on this side, the light is enabled. Basically what this is saying is if light is on, off. Or if light is off, turn it on. Yes. So a good way for switching variables to be on or off, or true or false if you have a bool variable, is to use this little selector. My light equals not my light enabled. Rather than saying my light enabled equals true, my light enabled equals false, we can just flip between the two. So yeah, the return type of the function is void, followed by the name of the function. All functions start with a capital. And then the parameters of the parentheses, if any. So this is what we call the arguments. Certain functions might take extra parameters in here. A lot of functions, if we write our own custom functions, we can leave that blank. Just know that after the return type and the name, it has to have those brackets. So 2 parentheses, and then we open the code block with curly bracket open and curly bracket closed. Again, the essential syntax of our function. Return type, name with a capital, parentheses, curly brackets, and then stuff in here. Functions can do calculations and return a value. You ask the function to do something, process the information, then return an answer. If you use the type void, as I've just explained, then they are not returning anything. Classes. Last slide this way. So classes are collections of variables and functions. For example, this script is a class. Very important, the class name must match the file name, class name up here, for it to work. And then to be attached to the game object, it has to derive from another class, monobehavior, to use all of that Unity stuff. If we leave the monobehavior class distinction off, then we'll create our own custom class in Unity. Something you sometimes need to do. But for most of our scripts, we will be deriving from monobehavior, and the script name needs to match. If you create a custom class, then you'll be asked to serialize it. This just means it will be converted into simple data that Unity can read. Just means if we create a custom class, we need to make it readable by the Unity system. And before I finish this, let's take a look at these functions. So, int myvar, the function add2. So what do you think this function is going to do on awake?
It's going to add 2 numbers.
It's going to add the 2 numbers. Yes, correct. And if we look down here, we also have an if statement. If input get key down space, run my function.
It will turn off or turn on the light.
Turn off or turn on the light. Exactly. So it's checking in update every single frame, which is where we do all our controls, update. If we're getting key down, what does get key down mean?
Pressing
Just means pressing it down, yeah.
and holding it.
No, not holding it down.
Just press
Holding it down is just get key. We'll look at the difference to that as well.
It's like key up.
Yeah, key down, key up. So key down when you press down, key up when you let go. Mouse down, mouse up. Again, back to Figma. We're doing more Figma. So, variables, functions, and classes are just the basics of starting with coding in Unity. And of course, you can find a number of tutorials on Unity Learn to advance your coding skills. Good luck with that. And I encourage you to do that. Whew. The end of the notes. Time to take the attendance, but also let's open up Unity.